and I would like to talk a little bit about today's and future challenges with data I/O problems in general at scale. Talking to a lot of customers in the industry, we tried to come up with a map of different things that we're seeing, trends, questions, issues that people basically talk about right now. So in the very middle you see various types of workloads that people either run today in their environment, start planning to work in their environment, and basically where they see expansions in their workload environment at scale. So you see everything from HPC workloads, AI, analytics, big data. There's a lot of things going on. And so the surrounding of that is you see essentially all kind of different trending technologies, either ones that are already there or changes in technologies. Everything from NVMe, which is in everybody's portfolio right now, or people start adding that in their portfolio. People deploy more and more fat nodes, there's more and more GPUs, ASICs, all kind of hardware accelerators and special purpose accelerators being used. You see a lot of changes in scale. Growth of data is more and more and more. You see this in all areas of the industries. Everybody who does something at normal scale these days is going to get into bigger and bigger scales. People don't want to throw data away. You see people using all kind of tools and interfaces into data. And so we came up with this map, and so the three focus areas of this presentation that I would really like to spend a little bit more time on is we see a lot of changes happening, particularly in I/O performance and behavior. So people have more and more focus on latency. Workloads change a little bit from bandwidth and batch into more latency-related things. Byte addressable storage is a question that people come up a lot with. There's a lot happening in the security area. Security in the past in HPC was never really a big deal, depending on the area, but it becomes more and more a big deal. People need to securely share data either internally, provide multi-tenancy capabilities either internally or externally with other customers, and need to be able to provide a secure framework for data sharing, as I said, within or without, oftentimes combined although with auditing capabilities. There is more and more legal requirements coming up. When you look at Europe with all the laws and changes that are coming, there's more and more requirements even in HPC to have audit tracking capabilities. Another very, very big area where we see some significant changes happening is in the whole data management area. So making things simpler, taking all the tuning knobs away, systems that basically automatically configuring itself. There is a lot of work going on in cloud integration. People want to use stuff on site, but they want to be able to burst basically into the cloud. So there's a lot of areas that we're touching here, and I have a couple of detailed slides to go into this and talk about some of the challenges that we can tackle with today's technology, things where DDN provides some significant solutions in the area, and then talk also about some of the future things that we think need to be addressed. So we just published a couple of announcements. We broke a couple of world records over the last couple of weeks. There is a framework for workloads that people can repeatedly run against their own infrastructure to kind of provide an apples-to-apples comparison of system performance. The benchmark is called SpecSFS, and it runs various types of workloads. There are more industry or more enterprise-targeted workloads. Software build is one of them, which simulates essentially software builds in a very, very large-scale environment. What you see here is a setup that we used for the benchmark, where we had a couple of clients connected through an InfiniBand switch, essentially to a couple of nodes attached to an SFA14K, which was the previous flagship product from DDN. We just last week announced the 18K, which is our new flagship product. And I'm not going to go into much details about the technology. We have plenty of data sheets on the booth that you go into. I'm more focusing on the value the end user essentially gets out of those. And so we did run multiple different workloads. I want to highlight two of them. So one, as I said, is software builds. Essentially, it simulates multiple nodes in a cluster, basically doing compile jobs across a pretty large data set. It's very, very metadata intensive. It touches millions and millions of tiny files, reads them, writes them, basically exchanges them between processes. And what you see here is kind of a capped chart. So we kept all operations that took longer than 1 millisecond, and we plotted basically numbers from various vendors that published the benchmark results over the last 12 to 18 months. And so we basically plotted all of them when they do builds, what the latency result basically looked like in the report. And I'm not going to highlight any particular vendors or try to bash any particular vendor solution. The key message is, so with our DDN setup that we run the benchmark with, which is pretty comparable to most other setups that were used before. Some are a little bit smaller, some are a little bit bigger, so it's not a really 100% apple-to-apple compare. But we were able to deliver 25 more builds than the previous system at 1/3 of the average latency compared to the previous result, which is very good, particularly given that the system was running with SSD drives instead of using NVMe drives. Our platform is capable of running NVMe as well, and we publish another record that is going to break the previous one with an upcoming hardware platform, but we used one that is more economically, so there is a more direct comparison between the other systems, and we have a very, very good result with that. So the second setup looks slightly different because we use a different platform that we're supporting. We have two products, one is called GridScaler, one is called Exascaler. So GridScaler is more for low latency workloads, something that deals with massive amount of metadata. Exascaler can deliver can work in this environment too, but has significant advantages, particularly when it comes into sequential and large block I/O workloads. So the second benchmark looks very similar to the previous one, a couple of differences to note. The number of clients is almost the same, these are 16 versus 19 clients. The network setup essentially looks almost identical. The key difference is that the file system itself actually runs inside the appliance itself, so there are no external servers that were used for the data portion of it. There is only a metadata server on the side that was used for the setup. And the previous setup was using SSD, while this setup is using HDDs, because the workload that we were running here is a workload called VDA, stands for Video Data Acquisition, which essentially simulates video streams that people play back, basically go backward and forward within the video stream. And so this again is a very nice representation of the results. So you see it's the red line here. So with that SFA setup, we were able to deliver 65% more streams than the previous submission, while having roughly the same number of drives than the previous system. But our system was basically 2-fault tolerant, rate protected, while the former top one submission was only doing a mirrored setup. So we are far more cost effective while delivering a significantly higher performance with the setup. What we also see, going a little bit from today in what's going on in the future also is, we see that there's a lot of challenges in the I/O behavior itself, from traditional workloads to modern workloads and also upcoming workloads. There is a significant shift from sequential into random I/O. So particularly if you're looking at all the AI and machine learning frameworks coming up, people no longer see megabyte I/Os, people see kilobyte I/Os. A lot of it is basically event driven. You start an I/O to find out what the next I/O is that you need to do in the I/O subsystem. So there's a lot of workflow changes and processing changes happening. There's a massively increasement of metadata that we're seeing. Before, people had basically large files and they had a little bit of metadata attached to it, or there were external sources like databases that stored metadata to it. People more and more try to combine metadata and data in one and the same system, because if you build system at very, very large scale, the index basically and the data can get out of sync, and it's really hard to get these things in sync. So we see some significant shift in this area as well. And so also a lot of these events are really, really driven by the previous outcome of the result. So there's a lot more mixture and a lot of more interaction between individual data sets happening. So there's a couple of ways you can accelerate this, and there's going to be an updated chart tonight, because what I'm showing you here is a couple of results from the IO 500 benchmark. So we are the leader in the IO 500 benchmark right now. There is a system that we have at JCA HPC running an IME system. So IME stands for Infinite Memory Engine, which is essentially an IO acceleration technology that we sell from DDN. It allows you to basically do overlapping I/O across significant number of nodes. We have a very, very nice way to basically streamlining the incoming I/O, so multiple nodes to the same data, put them into a log-structured file system, so we are able to write them in a very flash-friendly manner without basically providing significant increase in write amplification. So it's very, very economic for the flash devices. And then you can leverage HDDs essentially as a capacity tier behind it. So you basically put this between your workload clients and your existing distributed parallel file system, and it accelerates small IOs and overlapping IOs into the same data. There's other technologies in GridScaler, for example. There's Hawk and LRock, which are read and write cache acceleration technologies that you can use today as well. So in the whole security environment, as I said, there is a lot of upcoming requirements that we have. We see more and more customers that need a significant amount of data that they're collecting, but they have all these challenges on performance. The noise neighbor issue. You need to provide some form of quality of services between all these different neighbors. You see more and more requirements in the area of resilience. If you have 100 consumers and something happens in the system, you don't want the 100 consumers to be affected. You want individual, or you actually never want anything to go down. But if there's some significant impact in the system, you want the smallest amount of people essentially be affected. So there's some more work that needs to be done in this area. We see more and more the shift into virtualization. The customer want to have storage services to be delivered in containers. So we have a very, very strong roadmap working on containerizing our applications as well as all the software solutions that we're providing out of DDN. And there is a lot of efforts that need to be done on auditability, events for the system, end user access to the data. There is more and more things that need to be done in this area to satisfy a lot of requirements. And what we're seeing is, while there is a lot of solutions for many, many of these problems, most of them today are essentially an afterthought into existing storage environments. So a lot of the software stacks have been grown over a long time, and a lot of these things have been added later. And we're trying to basically drive a roadmap where we try to provide a more native integrated approach into these new upcoming frameworks to basically deliver on those requirements that we see coming from customers. We started some of these work already in Lustre, for example. We took some strong approaches towards multi-tenancy support. So some of the later releases of Lustre added multi-tenancy support, so you're able to essentially take a larger file system tree, subdivide it in multiple tenants, and essentially provide a secure way for customers accessing that without essentially having access to each other's data. It's really kind of separation of their access within a large, gigantic namespace. What we see as something that hasn't really been addressed, which is something that we try to work on, is to provide dynamic views on some of the data inside the system, where based on policies and rules, people get basically dynamic namespaces assembled where they see data that is relevant for them, irregardless of what data is essentially stored inside the system at the current point in time. There's a lot of other challenges in data management that we see. I've mentioned some of them before already. So the metadata growth is very, very substantial. In fact, we had some conversations with the customer just today again. We are ongoing in conversations with them. We have one customer that wants us to store 1 quadrillion objects within a single storage system. I actually had to look this up myself because I didn't out of my head what that actually is. It's actually 1 million billions, which is basically a 1 with 15 zeros, which is a pretty significant number. If you look at most of the systems today, none of them get even close to it, even if you have like an order of magnitude or more increasement of scalability. And so we work on some technology to basically get into the realm to be able to store these kind of data services. And so there's a lot of challenge there. Another thing that we constantly find is this problem with customers not being able to find their data or users not being able to data. So we believe that there needs to be some enhancements in extended metadata searching capabilities, tagging of data, policy-driven tagging of data, and some automation in tagging of data, and then providing the appropriate tools for people to essentially find their data within the system. Tiering and a lot of other data management things or aspects is still a huge challenge, and so we provide or try to provide some enhancements in the upcoming releases for that as well. So we recently acquired a company called Tintri. So Tintri has nothing to do with HPC. It's a pure enterprise play essentially. And one of the reasons we acquired Tintri, beside also having a foot and going into the direction of enterprise, Tintri provides an a very extensive framework for analytics at significant scale. They have capabilities to basically look into virtual machines, what workloads are going on there, what's the usage. They can set up various types of data management capabilities based on analytics. and we try to leverage that technology to also apply it to some of the other data at scale problems that we try to tackle within DDN. So we're going to use a lot of that information to provide end users more insights into their systems. So conclusions, so there's already a lot of different things we're doing trying to challenge some of these problems. We have a lot of exciting products that address some of them. I mentioned IME for acceleration, the various SCADA products we have. We have a very good monitoring tool called Insights, and data flow is the latest addition in our product portfolio, providing you data copy and management capabilities at very, very large scale. And we're significantly investing in engineering skills within DDN to challenge a lot of these problems. Glimpse into the future of I/O. I found this picture very nice, so I wanted to add it as the last slide in the deck. If you have any questions, I'm more than happy to answer them. Thank you. No questions?
Your both industrial and academic customers.
Sorry, can you repeat that?
You mentioned that you have both industrial and academic customers, is that right?
Oh yeah, a lot.
And so where do you see massive differences in, or
Yeah.
how does it compare?
So
from
there's
your perspective as a vendor?
Yeah, so there's a lot of the same requirements, but they are at different scale. So what we always see is a lot of the industrial requirements today is kind of what HPC requirements were from a scale and performance perspective a couple of years ago, and that trend seems to continue. So whatever HPC is doing today, a lot of the industrial customers going to do tomorrow or in a couple of years down the road. We see a significant higher actually growth on the industrial side. You know, that gap is closing, but the gap is really large. But if you look at some of the workloads, like for example in bioinformatics, genomics, all these different areas, there's significant growth. Some people call it HPC, and it actually is HPC when you look at the infrastructure and a lot of the requirements these people have. But there's very significant differences in terms of how early some of these, for example, data security, for example, features are required. So if you work with any patient data or anything that is, sensitive information, obviously in the industry there is a significant higher requirements also from a legal perspective for some of these things, and they typically tend to prefer or favor a lot of the security things while are happy to take some hit on performance, while in HPC the performance aspect is typically like number one. They want to do all these other things too, but it typically always follows like the performance aspect, and we see that there is some changes happening in this area as well. Does that answer the question?
Yeah.
Okay, thank you. Any question? Sure.
Yeah, second question.
Sure.
Now, if I understand correctly, you deal with on-premise installed infrastructures, is that correct?
Yes.
Do you see at all questions from customers about replication, multiple locations, and that sort of thing?
Yeah, actually with a GridScaler product, there is a functionality called AFM. AFM allows you to essentially interconnect multiple different sites together and collaboratively distribute data. So with the data flow product we just added, we also have replication capabilities between one and multiple locations. So you can keep information in sync at a very, very large scale. So yeah, this collaborative aspect is definitely something we see more and more sites and more customers trying to do, including also the move to cloud. There's a lot of requirements where people want to move data to the cloud and then use this as kind of a burst. But this is kind of seems to go up and down and depends heavily on the industry that you're talking to. But yeah, these kind of requirements we see on a pretty fairly basis.
Thank you.
Sure, welcome. Any questions? Good, then thank you.
Thank you very much.
Sure, thank you.